Yesterday we looked at roots, square roots in particular. Today we're going to look at how to do other types of roots. The first problem on your note sheet says the volume of a sphere can be formed by using the formula volume equals 4/3 pi r cubed. They want us to find the radius of the sphere if the volume is 225 cubic centimeters. Okay, well, they just told us in the end of this one that the volume's 225. So if we put that into our formula for V, what we have is 225 equals 4/3 pi r cubed. Now we want to solve that. In order to solve that, we want to do the opposite in each step. So we're trying to isolate r, get r by itself. So we want to go through and solve. One thing that we could do here to get rid of some stuff is to divide. We can see we have this fraction 4/3. Anytime you want to get rid of a fraction, you could divide by the fraction, or you could multiply by the reciprocal. So that's what we're going to do here. So multiplying, we're going to multiply by a reciprocal of 3/4. And we do that to one side, we got to do it to the other side as well. So now our two fractions cancel out. On the calculator to do that, we'll type in 225 times 3/4, and we get 168.75. All right, so now we're closer to our goal of getting r by itself, but we still have that pi over there. It's being multiplied. Anytime you don't see any symbols, we know there's a multiplication symbol there. Opposite of multiplying, divide. So next we're going to divide by pi. So again, we'll use our calculator here to divide by pi. And dividing that by pi, we get about 53.71. All right, now we get to this step. How do we undo a power of 3? And this is what we're going to be looking at today. To undo different powers other than when something is squared, you're going to use a radical or a root. And in this case, since this is r cubed, we want to do the cubed root. So what we're going to do is take the cubed root of both sides. So what we're going to end up with is r is going to equal the cubed root of 53.71. To do cubed root on your calculator, there's a couple different ways depending on the type of calculator you have. Somewhere in your calculator, sometimes it's under this math menu, you should be able to find a symbol that looks like this, where they have a square root with an x. That allows you to enter whatever root you want to do. Oftentimes, this button may be right above your exponent button on your calculator. So you might have to hit the shift button and then your exponent button, and you can locate this. So here we can see that. So what you want to do, it depends on the type of calculator you have, how you input it. But on this type of TI calculator, what you want to do is hit the root 3, select that function on your calculator, x square root. So this, let's say, this is telling your calculator you want to do the third root, and then type in your number 53.71. And if we hit equals, it tells us that the radius of this circle should be about 3.77. And we're in centimeters. So that's how you can undo different powers, and we'll look at some other ones as we go here today. All right. So we're going to look at powers and the roots that go with it. The first one that we've done a lot with already is something squared. And in order to solve that, what you would do is take the square root. So if you got a squared equals 16, then to find the solution, we would take the square root. And remember, whenever you're doing square root, it's always plus or minus the square root of 16, which would equal plus or minus 4 for the answer. In words, we'd say that is the square root. How about if we think about it as negative though? What if it was square root of negative 16? Well, in this case, we would not have any real answers. Square root of a negative does not exist. There's not a real answer. There is an imaginary answer. We've talked about how to do this before. If you have a negative, you can pull it out and turn it to I. So this would equal I square root of 16. Square root of 16 is 4. So you could get 4I as your answer, but there is no real answer. Okay. All right. The next one, cubed root. If you're going to do if you got something cubed as an a cubed equals 27, to solve this one, we would take the cubed root of 27 and see what that is. So cubed root of 27, going on the calculator, we can do that. Type in a 3 for the cubed root. 27 should come out to be 3. This one's 3. Now, we would say this is the cubed root of 27 is 3. Now, last time when we did square, we saw that it was plus or minus 4. Would this one be plus or minus 3? Well, let's think about that. 3 times 3 times 3 is definitely positive 27. Is negative 3 times negative 3 times negative 3 going to be positive 27? No, it would be negative 27. So this one is not plus or minus because negative 3 gives you a different answer. It's a negative answer rather than a positive answer. But if we come over here to our last column, what's the cubed root of negative 27? There is an answer for that one that does not include I. It's not an imaginary. It's a real answer. It would be negative 3 because negative 3 times negative 3 times negative 3 is negative 27. So we'll kind of keep that in mind and see if we can find a pattern here as we go with some of these different powers. All right, next one, a to the 4th power equals 81. We can find the solution to this one by doing the 4th root. So this time we're going to do the 4th root. So we're going to hit 4 because we want the 4th root. And we're going to type in 81. And the 4th root of 81 looks to be 3. Okay, because 3 times itself 4 times equals 81. How about, now let's talk about plus minus again. Is there going to be plus minus with this one? Is negative 3 times itself 4 times also 81? Yes, if you multiply an even number of negatives, it would equal a positive 81. So this one could be positive 3. It could also be negative 3. So this one is also a plus or minus one. All right, so if we look at negatives under the square root for our last column here, then is the 4th root of negative 81 going to have a real answer? And again, this one does not exist. There is no real answer. There is an imaginary one, though. We could, again, do it with I, and the answer would be 3I on this one if we pull the negative out of the root. All right. 5th root of 32. Again, you can use calculator to try this one. Let's see what the 5th root is going to be of 32. Type it in, you get 2. Is this one going to be plus or minus? No, this one only is going to be one answer of 2. The 5th root of 32 is 2. All right, so is there an answer for the negative one? Yes, if you multiply a negative 2 5 times, you would get negative 32. So this one does have an answer of negative 2. All right, so what do we have kind of in general then? Anytime you got a to some power, you're going to do you're going to do that. If it's to the nth power, you're going to do the nth root. So the nth root of b would be the solution to this one. What's our pattern? Did we discover any patterns with this? Yes, if you notice, all the odd roots any odd roots, we only get a single solution. Okay, as in the third root of 27, there's only one answer of 3. The fifth root of 32, there's only one answer of 2. With even roots, you get 2 solutions, plus or minus. You can get the positive or the negative. If we look at the last column when we did square roots of the negatives, there's also kind of some patterns here. Odd roots, if we look at the odd roots of negatives exist. Odd roots of negatives do exist. When we did the cubed root of negative 27, we got a real answer. When we did the fifth root of negative 32, we got a real answer. How about with even roots? No real solutions. So even roots of negatives, no real solutions. We can get imaginary solutions, but no real solutions. So even power ones, like square root of negative 16, no real answers. There is an imaginary one. Same with fourth root. So those are some patterns that you see. All right, well, what we're going to do is kind of use this now to apply it to some roots. In number 1, they want us to figure out what's the square root of 25x to the 4th. So when we're doing that, you want to start out with the number part. And the number part, you can use your calculator. Square root of 25, we've done this one before. We know that is going to be 5. But we also need to take the square root of x to the 4th power. So when you're doing square roots, with all the other roots, they always put a number there. With square roots, they don't just because it's used so often, but really it's like there's a 2 there. So we got to figure out what is being squared, what power of x is being squared that would equal x to the 4th. So if we think about that, you would have x squared being squared to equal x to the 4th. So the answer would be 5x squared. Really what you do is when you're dealing with powers, you take the power here and divide it by the root number and you would get the solution, so 5x squared. Let's try another one, number 2. On this one, we do see we have a negative. The negative, however, is not inside the square root, it's outside the square root. So we can just put that down in our answer. That negative is just going to fall right down to our answer. We're really just concerned with the root part of it. We have y squared plus 2 to the 8th power, and then the square root of that. So again, there is a little 2 here that's not written, but we know it's there. So we got to think, what do we get if we take this power of 8 and the root of 2? What did we say we do? We divide them. So 8 divided by 2 would be power 4. So we're going to get this y squared plus 2 is going to end up being taken to the 4th power. And that's the solution. So with roots and exponents, you want to divide them to figure out what it is. All right, let's try one more here. On number 3, this one's the 5th root. So 5th root of 32, what's that? And this is where you can use your calculator again. We have done this one back up in the little note section. The 5th root of 32 comes out to be 2. Now we want to do it with the exponents here. And again, exponent, you want to divide with the root. So if we take 15 divided by 5, that's going to be x to the 3rd power. If we do the 20 divided by 5, 20 divided by 5 is going to be y to the 4th power. And that's dealing with roots. We'll look at some more of these in class.